right, 30 more seconds for stragglers. Any preemptive questions people have before we even start? Is this the session you're all here for? Good.
Just how easy is it to crack Drupal?
Well, so I'm actually going to be, this is more of a broad web application security talk as opposed to, I'm not actually going to show you how to break into Drupal site. You guys see me on the side, or slip me a 50 if you want that knowledge. But yes, okay, so this is Cracking Drupal. I'm Peter P. Wolanin on Drupal.org or other places. If you don't know me, I'm a Drupal core contributor, also a member of the Drupal security team. So the members of the security team have over time done presentations, this one and similar ones, to do kind of a general education in the Drupal community about web application security, because really it actually makes our lives as volunteers much easier if module maintainers or other people don't screw up and don't have security vulnerabilities, then we don't have to deal with them. So that's kind of the goal here, is to give you kind of an overview of web application security, things you should think about when you're writing code, especially code you're contributing back, but also for your own projects, your own sites, things like that. So basically, going to use the framework of the OWASP Top 10, so I'll talk to you a little bit more about that if you don't know about that already. We'll mention best practices very briefly, certainly have time for questions, and hopefully you guys enjoy the session. So, I'm going to start with sort of the big pictures. So, first big picture is what's called the CIA Triad, or you can call it the AIC Triad if you don't want to get confused. So this is really, if you want to fundamentally think about what does security mean. Like if someone said to you, what does software security mean? You should be like, this is what it means right here, and you get an A in your class. So the A in your class is saying software security means confidentiality, integrity, and availability. So the data that's supposed to be private stays private. People that are not supposed to be able to modify the data are not able to modify it. And when you need to access it, it can be accessed. So these are like the fundamental tenets of kind of software security. And if you don't have all three of these things at the same time, right, your software is not secure, right? If anyone can get in and modify your data, clearly it's not secure. If someone can access your private data, it's not secure. If you can't get to your data, well, it's not very useful to you. You could say that basically it's not, you don't have security. You're denied access. There's denial of service attack on your website. It's not secure if that can be done to it. So this is basically a big picture framework. We're not going to talk a lot about this, but again, if someone asks you, you go back to somewhere and someone has a pop quiz and says, what is software security? You should say this CIA or AIC Triad is the fundamental definition of software security. We're going to focus on specifically on web application security, and we're going to use this framework of the OWASP Top 10. So OWASP is the Open Web Application Security Project. If you don't know about it, it's an interesting website project. They have a lot of useful resources. It's not PHP or Drupal specific, but they do have some PHP specific tools, as well as a lot of broad web application tools. And this OWASP Top 10 is kind of the thing, again, it's like if someone gives you a pop quiz and says, what are the most important web application vulnerabilities to know about, you should be like, I know the OWASP Top 10 right here. Right? So if you can't say the OWASP Top 10, at least say that, and you can always look it up. But they revise these every few years. So there was a revision in 2013, and then there was a revision in very late 2017. So that's the latest version. So what I'm going to show you is from this latest 2017 version of the OWASP Top 10. That's the URL for it. Obviously, you know how to use Google. And so this is the OWASP Top 10. And so this is basically the framework I'm going to use for the talk, is to go through these top 10 and then give you, for most of these, some kind of example in a Drupal context or PHP context, and tell you a little bit about what that vulnerability is, and then what it might look like in terms of Drupal code in the cases where there's like a code example to show you. Some of these are pretty broad, like there's not a specific code example to show you, but in other cases we'll dive in a little more to a specific code example. So, all right, so I'm not going to read through these, so we're going to touch on each one of these. You'll see them again. That's the OWASP Top 10. And let me, okay, so I don't have a slide saying this, so let me just pause here and say the ordering and the things that are in the top 10 are based on basically their importance to web applications in the world today. So they build this top 10 based on surveying people who run web applications or websites and ask them, what kind of attacks are you seeing? What are the most important vulnerabilities to your web application today? What are the things that cause you the most problems? Right? And so they do a survey. So this is based on a survey. It's not, you know, and then they process that survey and then they add or remove things from this top 10 list. And we'll cover one at the end that's been removed from 2013 to 2017. But it's still, I think, important in the Drupal context. And so some of these things are definitely not important for Drupal, right? So there are a few things here that are pretty marginal in terms of Drupal, but they might be really important. Let's say if you're running a Java web application, this might be the kind of thing that you see regularly. So again, the thing to think about as we cover this top 10. So number one, this is the vulnerability that is both potentially common, but also has the highest impact. So number one vulnerability is the highest impact. If you have this kind of vulnerability on your site, you're screwed, right? Hands down, game is over, you're screwed. Number two, you're also basically screwed. Number three, like, you know, okay, like you might be able to deal with it tomorrow, you know, and so on as we go down, right? You know, but basically by the time you get down to like 8 or 9, you know, if you have that kind of vulnerability, okay, you might be able to sleep till tomorrow until you fix it. But, you know, the top several, these have really high impact. If you have this kind of vulnerability, you need to deal with it right away. This is like, you know, whoever wrote that code should be sent back to remedial coding school, whatever. But again, like, you know, it's hard, right? Because we've had these kind of vulnerabilities in Drupal core. And you think about it, some of these vulnerabilities were in Drupal core for literally 7 or 8 years before anyone noticed. So these vulnerabilities can be quite subtle, even though they're high impact. You know, severe vulnerabilities, these kind of vulnerabilities can be subtle. It's not, you know, again, I'll show you examples that are really dumb examples, like don't do that. But like in the real world, these vulnerabilities and these code, you know, mistakes can be quite subtle, and it can be pretty hard until someone, you know, finds a path and compromises your site. You're not going to realize that you had that vulnerability. Okay, so again, this is like, these examples are, you know, 101. If I wanted to write bad code, this is what I'd write. But you also actually see these in real world, in production, all the time. So, you know, both sides of the coin there. So number one vulnerability, most severe, most important thing you should never do is have injection, which is basically code injection, which means the attacker can execute some kind of code directly against your web application. Either PHP, shellcode, SQL, all these things count as injection. And so two really, you know, obvious examples here, right, is like in the Drupal 7 context, is someone interpolates a variable from the query string directly into an SQL query. So you see that get user. You might have been expecting a user ID, like an integer there. But the attacker was like, hey, if I put an SQL statement in there, it'll execute. Great. I can now select all users. I can select, you know, if this is part of a login process, I could basically force this to return true. So, you know, I got user 1 instead of whatever user ID you were looking for. So there's a bunch of things, right, where you could use this, even if you couldn't change the data, you could use it to, you know, bypass authentication. You could do other things and get extra data out of the system. Basically leverage this to, you know, into any other of the vulnerabilities we're talking about. Equally and more secure is, you know, someone uses eval on some kind of user input. Again, this is really obvious user input, right, is the post data. This kind of thing, you know, again, I have actually seen this in Drupal modules on Drupal.org, this kind of code. Yeah, someone's like, hey, I wrote a module that provides you a shell onto your system, and it takes the post data and it executes it. Yeah, it's horrible, right? But people write this stuff, they post it. So you need to be aware that this is obviously really bad. This, more often you will see if someone has compromised your site and they put like a remote shell application, this is the kind of, or compromised your site and left a backdoor, this is the kind of thing they might leave on your site. So again, this is injection, the most severe, the thing you don't want to have happen, highest impact, can completely compromise your site, can potentially compromise underlying servers, And, you know, unfortunately, we've actually had a few of these in Drupal core over the last few years. So you guys may remember the 2014 SQL injection. Again, this was something that was in Drupal core literally for years before someone noticed it. A subtle mistake that someone forgot to call array values on an array before they for eached it, literally. And you know, so that didn't require authentication. Anyone could execute SQL against your site. It was pretty terrible. Had similarly almost as severe ones in 2018. Some vulnerabilities. Again, this vulnerability in various forms was present for literally, I don't know, like a decade, right? And no one had noticed until someone clever traced through and realized that this was possible. And then once it becomes known that it is possible, other people were able to find the exploit. So the first one was terrible in that, like, about 6 hours after we released the announcement, people's sites started being compromised by attackers who found the vulnerability. This second one, it took a couple of weeks because the vulnerability was more subtle. It wasn't as obvious how to exploit it. Then we've had a couple recent ones, FAR file execution. This is a little more marginal, but you know, if you'd allowed people to upload FAR files or files to your site, they could potentially execute code. And then again, a more severe one, if you're using various REST modules, there was an unsecure unserialization process that again could be leveraged into other kinds of code execution. And then we'll get back to these unserialization vulnerabilities, but that was the avenue for it. So that was the most severe. So if you have code execution, again, the attacker can do anything they want on your site. Game is over. You know, if something comes out in Drupal.org and it's like highly critical code execution, you should update literally as soon as you possibly can, because again, that first case, it was only a matter of hours between the security announcement and when sites were compromised. You know, that was terrible. People are still, I know, pretty burned by that, but you know, that's we'll talk about the security team release process at the end, but yeah, we didn't have a good way to help people and trying to actually improve some of the processes as we go forward, so people have a little more advanced warning when we have if we ever have a severe vulnerability like that again. So number 2, broken authentication. So this one in the OWASP 10 is perhaps the most obvious one. Like, you just read this and you're like, okay, I understand. Someone can log into the site who's not supposed to log in. So clearly, choosing good passwords or forcing users to comply with a password policy, using two-factor authentication is important. He's not in the session, but Adam is here, who's a maintainer of the TFA module for Drupal 8, which does not yet have a stable release. And I was harassing him earlier, and he swore that it would be coming soon. So again, you know, consider using that for Drupal sites. If you're writing your own web application, like let's say you're writing something with Symfony, do not store your passwords in the database in plain text. Make sure you use a secure hashing algorithm to store them. Drupal core obviously covers that. Session IDs. So great news, Drupal 8 actually stores the session IDs with an extra layer of hashing in the database, which means your database dumps are not as vulnerable as they might have been in the past. That's also great. People can still steal a session ID if you're using your website unencrypted over an HTTP, not an HTTPS session. So again, you know, part of holistic security is using HTTPS for your websites. You should ideally use that for all sites all the time on every page now. Force users to use that. It also actually can potentially help you with your site performance, because the HTTP2 protocol is basically only implemented for secure connections. So again, we're in 21st century. Use HTTPS. Okay. Topic number 3, OWASP Top 10, sensitive data exposure. Again, this is pretty self-explanatory in a way in terms of what the vulnerability means. You know, credit card numbers, people's passwords we already covered, their social security numbers, you know, their date of birth or something that they might care about being exposed, their medical records. People might be pretty pissed off if you expose that to the public. The best approach to avoiding this vulnerability is to not have it in the first place, which means don't store that data. There are a lot of third-party services now that handle credit cards. If you want to take payment from someone, unless you are a major enterprise, you have a security team, you have a team of developers dedicated just to payment processing, you should be using a third party. Similarly with if you're storing medical data, don't do it. If you, at all you can avoid doing it, if you can avoid storing it in your Drupal site, outsource that to a third party. To a degree, that's also true even with authentication, with passwords. If you can use a third-party service, let's say you log in with Google, instead of collecting user passwords, that's actually a good option. You're not even storing their password at all. If your site database is compromised, it doesn't matter, right? The attacker couldn't get their password even in a hash form. So that reduces your risk level. If you're storing things like credit card numbers, medical data, you probably had better be encrypting those, at least when you store them in the database, right? So that would reduce your exposure. If someone gets a dump of your database, they wouldn't be able to decrypt the data. But that's very tricky. So now you're in this whole problem of key management, right? And so if you have a weak key for your encryption, if you don't manage your key, if you commit it to Git and push it to GitHub, which has happened all over the place, like you search GitHub, you can find people's AWS keys, encryption keys, all kinds of things in GitHub, right? Those you can be exposed. Again, HTTPS for all traffic. And again, if someone can get access to your database dump, can get even access to the hashed passwords in the database, the attacker can run that algorithm. They can test, let's say, a lot of common passwords. Have been exposed large caches of people's passwords, thousands of commonly used passwords. They can just take all of those, test them against each user in your database, and see if they use one of those common passwords, and pretty quickly find a login to your site. So all these things, sensitive data, exposure, OWASP up to 10, number 3. So bad if you have that on your site. Okay, so that was, I feel like those were all, again, if you had any of those, you should not sleep until your site is fixed. This gets into one now that we're a little bit more esoteric. We have had versions of this in Drupal, but not as severe. So XML External Entities, or XML entity attacks in general, let's say, is not something that Drupal doesn't do a lot of XML parsing. Again, this vulnerability in the OWASP 10 is mostly there because of things like Java or other applications that do a lot of XML parsing. But just to be aware, if you have one of those applications, you're working with people, a lot of XML parsers will actually parse and reference URLs in the XML. And so if you're an attacker and you can get the site to consume your XML, you can do things like putting in an IP address instead of a file system path. Or something like that, and then by doing that, you could potentially trick that web application into doing like a network scan, and basically accessing things, let's say, on their private network, and returning the content of a web page on the private network instead of returning the content of a file on the web server. So basically, any place that these are affected, if your Drupal site, again, let's say, imagine your Drupal site is consuming an RSS feed from some remote site, you could be vulnerable to this. If you're using SAML for logins, that's actually an XML format. Somewhere in there, Drupal is parsing, or PHP is parsing the XML. If you have this kind of vulnerability, an attacker could potentially tamper with the XML that's being sent through the different redirects during the SAML login process, right? And it's actually in a sense, user data, right? You don't have control over it. The user could tamper with it, change that SAML response, put in some kind of remote URL into the SAML, and potentially bypass authentication, pull in some other data, and get it potentially exposed to them. So
this isn't really limited to XML, though.
Well, this one,
JSON if you're consuming that.
Yeah. So right. So in general, user data is dangerous, right? So any user data, if you're parsing it, is dangerous. This is XML specific in the sense that you don't necessarily have control over the way it's parsed, right? So a lot of XML parsers, you might not know or even realize that an attacker could basically substitute an attribute value for an external URL and have that be actually fetched, right? So that's why this one is on the OWASP 10 because a lot of people don't pay attention to what's happening in the XML parsing, and then they get vulnerable to this because they basically trust some incoming XML as being safe. So yes, you're right. Anything you're parsing that comes from an external source is potentially dangerous, but XML is particularly dangerous. Okay, so that one again, less important for Drupal. Broken access control, again, a little bit self-explanatory. We don't have too many of these in Drupal core, though certainly versions of them happen. This is a very common vulnerability in Drupal contributed modules. So some kind of access control is broken. You'll see, if you look at security advisories, you'll see access bypass. Basically, that's the equivalent of this broken access control. It means someone can access data that they're not supposed to see. Again, the sort of dumbest example is a page callback that displays some content without checking that the user has access to it. So here's a code example for Drupal 7. You guys have probably all done this. At some point during development, you're like, hey, I want to just be able to access this form because I'm developing it, and I'm just going to put the access callback as true. I don't need, when I'm done developing it, I'm going to fix that, and I'm going to put it into permission, and then you forget and you deploy it. It happens. Everyone does it once in their career, at least. So this is basically, what the base level example of missing access control, right? So now someone can access this form, potentially even change some data, administrative data. Anyone on the internet who can get to that path. There's not necessarily a link to that path. They would have to know it's there. But, again, if they knew it was there, they could get to it and they could access the site. The Drupal 8 example is very similar, right? So we have this requirements access true. This is what the Drupal 8 route definition would look like. It has the same exact problem, right? So anyone on the internet that knows this path can get to it and potentially submit that administrative form and change some setting on your site. Not a good idea. Don't do that. So clearly, like, the way to fix this, right, is don't put true. In Drupal 7, we can say that the access arguments is some permission, and Drupal 7 by default knows that we want to check user access. If you give it an argument like this, that's the default callback is user access. Drupal 8 is very similar. We say we have a requirement for permission and name the permission. So, you all know how to do it right, but again, as you're developing and you're doing the first pass and you're in a hurry to get it, working, it can be easy to forget, and have someone else review code before pushing it to production is always a good check for that. Similarly, node access, right? So it can be pretty easy. Let's say users are visiting my site. I want to present them a list of some kind of nodes. This is basically Drupal 7 example, but Drupal 8 almost identical. I'm going to build up a list of nodes, and I'm just going to do a query in some way. So if I don't add this node access tag in the query, Drupal will not check whether or not the node access system should be involved, and we'll just go ahead and present the list of all the nodes to the current user, right? And that might, again, be sensitive data. It might be things that are unpublished. It might be, next quarter's expense report or next quarter's earnings report, and they'll get a jump on you in the stock market. These are actual attacks. Again, access bypass attacks people really care about. They can get your earnings report before it goes public. They can make a lot of money. So if you're writing your own queries, writing your own list of things, think about making sure that you tag with node access for lists of nodes, and you will hopefully be not exposing private data. Okay. Phew. All right. So that was like first half of the top 10. Again, those are things that are severe. Most of them are pretty obvious. I'll give you a specific code example. Some of these next ones are a little more broad and harder to narrow down to like one specific example. So I'm going to give you kind of a range of examples. And this, it almost goes without saying, right? If you misconfigure your site, it's not secure. So I'm going to just cover a few examples here of common misconfigurations, I would say, for Drupal sites. Again, think if you're evaluating the security of your site or application, think about configuration management. So error reporting is one that attackers enjoy. If you are reporting errors to the screen, they can potentially trigger an error by putting in some bad data. It makes it easier for them to find out your file system paths and then potentially try to directly request files. It makes them easier to see when they've hit an SQL error and maybe explore ways to do SQL injection. So you should basically turn off error reporting for everyone, at least, or except for maybe administrators or on development sites. If you're still using Drupal 7, turn off the PHP filter module, or better yet, delete it from your file system. In general, we would recommend that your code not be writable by the web server or by the PHP process itself. It makes it very easy if there's a vulnerability in your site. This is the 2014 vulnerability. People were able to leverage the SQL injection vulnerability to then execute some code, to then write files and basically install a PHP shell in a lot of people's sites. So if it's not possible for the Drupal application or web server to write out executable code, it reduces your risk if you do get compromised. This is also a problem. A configuration is very common on shared hosting. So if you're using shared hosting, be aware that you may be vulnerable to this. There may be no way to configure shared hosting to avoid this particular configuration, because it's just that's the way it ships. They don't care about your security. They care about basically isolating one user from the next. So if you care about your security, probably don't use cheap shared hosting. Okay, permissions. So security misconfiguration. What roles for what users have what permissions on your Drupal site? Auditing those is useful. We try to flag in the user interface permissions that are dangerous, right? You'll see on that permissions page, a little subtext that says basically like this is a dangerous permission. Don't give this to a user you don't trust. The flip side of that is that often if there's a security vulnerability and it requires one of those permissions, the security team may fix it in public, because we're basically like, we went to the trouble of telling you not to give that permission to people. You gave it to someone. We're not going to hold your hand if they can now compromise your site. So be careful. Audit those things. Text formats. We'll get back to this again, but full HTML text format is the same as allowing someone to execute cross-site scripting. They can execute cross-site scripting. They can basically take over your site using all the permissions of any administrator who visits the site. Similarly, the user one account has no restrictions, right? There's no way to lock it down. If you use that account as a shared account, it means you also don't have any logging that's necessarily going to tell you who was using that account at any given moment. So best practice is to block that account. Don't let anyone log into as user one. Give everyone an administrative account. There's an administrator role that ships to Drupal 8 that basically gets all permissions. So it's equivalent. You don't have to use this account. And ideally, if you're not blocking it, don't give it a really obvious name like admin that someone on the internet could guess. But again, if possible, block it. Don't let people log into it on your team. Private files. Again, this is the kind of thing that is a very common misconfiguration, is that people have their private files somewhere under the web root. And again, if an attacker can guess the path to the private file system under the web root, they can then get the web server to directly serve the private files and bypass all of those access controls that you've worked hard to put in place. So if possible, you should put your private files directory outside of the document root so that the web server cannot actually serve those files at all. And that enforces the files being served by PHP, by Drupal, meaning that you can actually check permissions before someone gets that file content. So very common misconfiguration for Drupal sites, having private files inside the document root. Another one, PHP file execution. So Drupal uses what's called the front controller pattern, which means basically every single Drupal request that a normal user is going to make, it actually executes index.php. So what does that mean? You actually don't have to allow any PHP files to be executable in your entire document root except index.php, right? And your Drupal site will still work. So this is a great way to lock down and basically block certain kinds of attacks where an attacker might be able to upload a PHP file somewhere else in your file system and then execute it through the web because the web server says, oh, it's a PHP file, I'm going to execute that for you. So Drupal 8 with the HEAccess rule for Drupal 8 blocks at least PHP files and subdirectories because we still have things like update.php or cron.php that some people use, but you don't have to. You could actually not allow those either. You could only allow index.php, use Drush for Drupal console to do everything else. But again, at least disallow execution of things in subdirectories, and you'll be more secure in that if someone finds a way to upload a PHP file, they can't execute it and they can't hit that OWASP 510 number 1 of code execution. Right? The worst case, they'll be able to upload some kind of file content to your site. It's still bad, but not as bad as it could be.
Are there Apache rules that whitelist those 3, cron, index, and update?
So like rewrite rule for the 3 files.
Yeah.
So this
posted in a blog. So just grab this and drop it in your.
Yeah, I don't know one specifically. So you could certainly, basically only turn on PHP if the file matches index.php. So this one is kind of written the opposite way, right? It basically says deny access for anything that's in a subdirectory with a PHP extension. And that, it's, again, this is not the best rule, but it's sort of the thing that we could ship to most people and it would tend to help them. Right, so yeah, definitely if you're configuring yourself, if you have, or you're configuring Nginx or some other web server, you might only want to allow index.php to be executed and not any other PHP file at all in the document root. But yeah, it's a good question. It'd probably be good to post like the most secure example you can for those. And I don't know one offhand. Okay, so those are all. I mean, we could basically talk all day about how you could insecurely configure a Drupal site. And maybe if we get back to questions or if people have comments now on other things they've seen, we could talk about them. But otherwise, we'll move on to everyone's favorite cross-site scripting. So this one, we're going to spend a little time on because this is really the most common problem, or most common pretty severe vulnerability we see in Drupal. This is a little bit down the list of the OWASP top 10 because ideally it's not as common as some of these other ones. It's more common that people have some kind of misconfiguration, or it's both more common and more severe that people have a misconfiguration that someone can exploit. Let's say as an anonymous user, cross-site scripting often requires that you actually already have login access to the site, that you'll be able to, let's say, post content. So, it's down the list a little bit because of that. But very common to see this kind of vulnerability in Drupal, even in Drupal core to some extent, very common in configured, contributed modules. The definition is basically that an attacker typically is able to inject JavaScript tags. Sometimes in the old days might also be Flash, but that's not very common anymore. So, the way to prevent this, right, is that basically you have to sanitize all user input. So some way you have to escape or make sure that all the tags are validated in the HTML that any user posted, and that has to happen before it's printed back to the users. This is also a little bit down the list because some interaction is required. You as, let's say, someone with administrative privileges has to go to the site and go to the page where the attacker has been able to somehow prepare this attack. But that's actually easier than you think. So someone could email you a link. Someone could invite you to visit their blog post and redirect you to the page where they prepared the attack. So, this sounds like it's far-fetched, but in fact it's pretty easy as a targeted attack. If someone wants to compromise you specifically, it would be pretty easy for them to get you to visit the page where they prepared this attack. So the first kind of cross-site scripting I'm talking about is reflected cross-site scripting. We don't see this one so often, and actually some browsers now actually implement protections against this. by default, which is nice. But how it looks is basically if you took something from the query string and put it on the page, that could be leveraged as a cross-site scripting attack. Here's what that would look like. In your theme, you're printing basically the page number, looking at the query string, assuming that that's a safe integer and not escaping it. So this can be reflected. So someone could now, the attacker could basically construct a URL, and the number parameter in the query string could be actually a long string of HTML with script tags, and they could then send you that link in some way. They could put it in, bit.ly or something, right, and make it look like a short link, send it to you, say, hey, could you tell me what you think about this page? You click the link, you say, oh, it's a bit.ly link, it must be safe, right? You guys always check where bit.ly redirects you to, right, before you go there? Always, right? And now there's this long query string that contains a bunch of script tags. That attack might execute you and even redirect you somewhere else before you even notice it happened, right? And in that moment, they might have created an account for themselves on your website, sent themselves an email inviting themselves to log in as administrator. Game's over. Okay, so that's reflected. That's not so common. As I said, browsers now starting to implement some default protections against that. Much more common is persistent cross-site scripting. We see this all the time. It's less common in Drupal 8, super common Drupal 7 before. And the attacker's JavaScript, the attack they prepared is basically stored somehow in the database. That's where the name persistent comes from. And here's an example of vulnerable code. Drupal 7 example, Drupal 8 example looks very similar, potentially, though, again, Drupal 8 has some more protections we'll talk about. Can you see the vulnerability in this code? If you were code reviewing this, would this stand out to you as being vulnerable? I mean, I'm showing it to you, it's vulnerable, but again, it's not necessarily obvious, right? Just looking at it, why is this dangerous? It's because of the node title, right? The node title is user input. The user who submitted the node put whatever they wanted as the node title, including script tags or any other HTML. And if you don't escape that node title, when you as administrator view this list of nodes, right, it's in a table, right, that attacker's JavaScript could execute. Yep?
Do you know if entity metadata wrapper handles that?
What's that?
Escaping it?
I don't think so, no. In general, if you're just pulling out the node title, it's exactly what the user input. And that's actually an important principle in Drupal that we don't modify the user's data when we save it. And that means, right, that this potential attack is stored in your database, but it also means, maybe the title, this was a blog post about cross-site scripting, right, and it was supposed to have script tags in the title, right, but the script tags weren't supposed to execute. So, we don't want to modify it because, in fact, the user might have intended or you might have wanted whatever that content is to be in the node title. So we're not going to modify it, we're not going to strip it out when we save it, but when we display it back, we have to make sure it's safe. Right, so the easy way, here's the Drupal 7 example, right, is check plain. And handling text securely is actually a pretty complicated topic because of this reason I just described it. We're taking the user input as is, and we have to think about the context and our trust level for that particular user when we display that text back. Right, so we have to know who the user is, how much we trust them when we decide how we're going to handle that text. This is not kind of a one-size-fits-all. And I have a slide where I'll go through kind of that hierarchy. What I want to pause and emphasize is that cross-site scripting is really, really dangerous. People often believe that sort of probe of doing an alert is the extent of the damage that cross-site scripting can do. That's completely wrong. In fact, cross-site scripting, someone can execute a cross-site scripting attack on your site against you as the administrator. They can take any action on that Drupal site that you as the administrator can take. JavaScript can do anything basically you logged into your browser can do. So they can create user accounts, they can change permissions, upload files, create new content, anything. People often sort of pretend that cross-site scripting is just an alert or it's a defacement. It is in fact giving someone else control, equal control as you as administrator to your Drupal site. So There's an article here that's linked that has some examples. People have written scripts basically showing how you can write a little JavaScript that, as a cross-site scripting attack, will go in as you, as the administrator, and change users' passwords so you can log in as that user. So what I told you again is we're going to filter data on output to prevent cross-site scripting. So again, we store exactly what the user typed. We believe that there's some value, even if it's an attack. We still, we don't want to lose the data because it might be. So again, the conversions, the things to make the data safe, happen on output, not on input. So this is a very important rule. If you ever look at Drupal code and you're wondering like why is this code over here on output and not on the input? Basically, this is the rule. This is our basic principle of how we're handling user input. And so we have kind of a hierarchy. These are kind of the level of things from most restricted to least restricted. So something that might be most restricted that we can filter most severely is if we have something like a URL, right? So we know URLs should conform to some very limited format. We can validate them and make sure that they are not, let's say, a script protocol or some protocol we don't want. They could be only HTTPS protocol. Then we have plain text, right? So we can call check plain or an equivalent escape function in Drupal 8. There should be no HTML tags in that text at all after it's escaped. Okay, now we're in the middle ground. We want the users to be able to format their text a little bit. We want them to, let's say, be able to put in a strong tag, but not other tags. So now we're kind of in this rich text area where users are able to put in some HTML, but not all HTML. And so we have to then think about how we configure our text formats, what role can use what format. Then we get to almost full HTML. So Drupal has functions like filter XSS, which will strip script tags for basically not anything else. And that, you can probably not execute a cross-site scripting attack at that point, but you can deface the site. You could do a lot of things that would be kind of unpleasant if you had that level of access. Put in any kind of tags or markup you wanted. And again, finally, trusted essentially the full HTML format or equivalent, right? At that point, there's nothing between the user's input and the HTML output on the Drupal page. And at that point, that's when the user can execute a cross-site scripting attack. So again, there's kind of this hierarchy. And when you think about, you're looking at your code, you're thinking about how you handle user's content. There's almost no cases where you want to just print it out directly without filtering it to some extent. Again, there are a few in Drupal core where this happens, where we don't escape them at all, and there are things like user role names. So there's like a long-standing issue on Drupal.org. People complain, like, you don't filter the names of user roles. And it's like, well, okay, but if you can configure the user roles on a Drupal site, you already have permission to configure all the users and all the permissions. So you know what? It's not really a security vulnerability because at that point you've already had access to do everything on the site. So that's at the beginning where I said, there's certain permissions we flag and saying, this is a dangerous permission. Giving someone this permission is equivalent to giving them control over your site in some aspect. So something like if someone can configure the user roles and part of that data is printed unfiltered, it's not really a security vulnerability because they've already got access to everything in your administrative interface. Okay, so again, cross-site scripting is really bad. There are some ways we can mitigate it. So Drupal core does some things. So if you examine the cookies that Drupal sets, you'll see that it sets this HTTP only flag on your session cookie. It's done that for a long time. That means that JavaScript cannot access the session cookie, meaning that JavaScript, if an attacker executes cross-site scripting, they can't get your current login session and basically clone your login session. It's not a huge mitigation, but a little bit of a mitigation. Changing the current user's password requires the current user's password. That's a little bit of a mitigation, again, but an administrator can change other people's passwords, so it's not a full mitigation. Again, text formats for different user roles, and then a huge one we'll hit on again is auto escape in Drupal 8. So Drupal 8 is using Twig, and by default, all content that's printed to the screen is automatically escaped. And so you have to actually take an extra effort to allow any kind of HTML markup. Good news also, there are new W3C standards, so the content security policy. This is not enforced by default in Drupal 8, but you can, there is a module I'll reference later, you can turn on content security policy for Drupal 8. Basically allows you to block all inline JavaScript and all inline CSS also if you want, and allows you to potentially whitelist domains for third-party JavaScript being loaded by your site. So if you configure a content security policy that says there is no inline JavaScript at all in my Drupal site, those cross-site scripting attacks I showed you of either reflected or stored cross-site scripting now are completely prevented. So it doesn't matter if someone is able to somehow get their script tags into your node title and get it printed unescaped to the page. If you content security policy tells the browser that there should be no inline JavaScript and don't execute it if it appears on this page, that cross-site scripting attack can now blocked. So if you don't know about content security policy, I would definitely investigate it. Yep.
Isn't content security policy handled by each browser, though?
It is handled by each browser, right? So it is browser, if there's a bug in the browser, if users are using a browser that doesn't properly respect this, right, it's not protected. But in general, right, you know, browsers now keep getting auto-updated. People are kind of being forced to move to a current version of browser. And this has actually been around for a number of years now, just not widely implemented. Mm-hmm. So the browsers in general, like it's a fun thing to try, right? Right. Like set, you know, put some JavaScript on a page, set this header in, and you know, make sure that your browser is not going to actually execute the script. So again, yes, you're right. Like users can still be vulnerable if there's a browser bug. Well, you know, a lot of these mitigations don't necessarily, you know, can't handle that edge case. So it's you as the Drupal site owner can do your best to mitigate it. You know, and don't, you know, again, don't poo-poo this just because you're using Drupal 8. You still need to think about user input and how to escape it properly. Now we get into a fun one, a little more common than you would hope, is insecure deserialization. So this is in the OWASP top 10, and actually we've seen this very recently in Drupal core. And this is exploitable in PHP and lots of other languages. This has been a big issue for Python. This is a big issue for Java. A lot of different languages have the same kind of vulnerability in web applications. If you basically call some kind of method that takes user input string and turns that into an object, there can be ways to leverage that to execute arbitrary code. So in the example of PHP, an example is that there are classes shipped in Drupal core where the destruct method of the object can delete files from the file system. So if I can send in, so this is a nice, I'm not going to tell you the more severe examples, because I'm not sure they're public, but this one, if you go look for it in Drupal core, you can find a class, right? If you can instantiate that class as part of the constructor, you can give it a file path to a file. When that class goes out of scope, it will delete that file. So now basically any file on the file system that PHP has write access to, the attacker could delete. You know, again, so they're not necessarily taking over your site, but they could certainly, you know, delete important data from your site. They could, you know, basically cause your site to go offline. In other cases, they could execute SQL or PHP through similar methods. So we just had this recently. In some of the REST API calls, it was possible to send in serialized strings for certain fields of objects, and Drupal core would parse it, unserialize them, call PHP's unserialized method on them, and the attacker could have put in basically an object as a serialized value with a class that had this kind of vulnerable destruct method, and so Drupal would parse that and instantiate the object with the attacker's data into the constructor. Then, of course, it goes out of scope, calls the destruct method, and now your files are deleted, or the code is executed, or the other attack happens. Right? So, Basic mitigation for this is never use PHP's serialized format for any kind of user data. So think about where user data is coming in. It could be in the query string, it could be in the cookies, it could be in these API requests through REST. All those things are user data. You really don't want to have PHP serialized format in any of those because, again, users can potentially exploit this insecure deserialization and carry out attacks on your site. If you need to do that, and I certainly want to do this myself, for sometimes, let's say, form data. You want to store something as a hidden value in a form, fetch it back in the next step, use a safe format like JSON. Like, there's no way that JSON can be instantiated into an arbitrary class in PHP that has this kind of behavior. It's just going to come back as sort of a generic object if it comes back in as object. Okay, so getting towards the end of the top 10, using components with known vulnerabilities. This is so broad, it's sort of obvious, but it is so common. This is how everyone's Drupal site is compromised. Basically, if you surveyed the world and asked how did the Drupal site get compromised, this is how. They had a module or Drupal core and they didn't update it. And there was a known vulnerability. The attacker just looked around and found the site and said, hey, they didn't update. I know what the vulnerability is. I'm going to compromise their site.
All this mostly user error at this point.
Yeah, right. So, well, it is user error, but this is, again, very common. People aren't aware that there's a security release, or someone is paid to build the site, turn it over to the client isn't informed, doesn't have an ongoing support contract, doesn't know that Drupal has to be updated.
We also have situations where modules get major release updates, like 7.1 to 7.2.
Right. Yeah, or that can be a problem too, right? And I know we're struggling right now. We're trying to update things for JSON API to use the 2x branch, which is slightly different than the 1x branch, because we want to be ready for the version Drupal core. And hopefully those maintainers are responsible, and if there was when that Unserialization vulnerability happened, they did release an update for the old branch, but a lot of module maintainers have moved on and won't release a security update for old versions of the modules, or old branches of the modules, as you said. So, you have to pay attention, keeping things up to date. It can be a pain in the ass. You have to budget for it. You need to be on the mailing list. You can go to your profile on Drupal.org, sign up for the mailing list. There are RS feeds. And your Drupal site itself, if you have the update status module enabled, can email you. Hopefully everyone knows this, but you can go to your settings and put in your email address, and every time there's a security vulnerability, your Drupal site will email you on cron saying, hey, come update me, come update me, come update me, every time it runs cron. So this is a good thing to do, or let's say you're turning the site over to someone, configure this and say, hey, if there's a vulnerability, the site's going to email you, and you're going to have to deal with it. So again, these are, this should be standard. Everyone should be doing this, but surprising how frequently it's not done. Drupal 7, end of life is happening. 2021, the date is already announced. If you're not prepared for Drupal 7 end of life, there potentially will be some long-term support that you could pay for, but vulnerabilities for Drupal 7 after that point may or may not be fixed. They may go public, and you may be vulnerable without any way to patch it. So, I know it's hard to hear, but Drupal 7 has had a great run. It was released in 2007. So 14 years if you've been using Drupal 7, it's time to update to Drupal 8. Or pay for that long-term support, and hopefully those people will provide it. Drupal 8 will also be end of life on the same day. So if you're not paying attention to the Drupal 8 to Drupal 9 upgrade path, that's something you should start thinking about. Ideally, it will be much easier than the 7 to 8 path. Basically, the idea is that the last release of Drupal 8 and the first release of Drupal 9 will be the same, except that all the functions that are marked as deprecated will be deleted. Right, so you can actually start now running automated tests, turn on flags, so that if deprecated functions are called somewhere in your automated tests, your test will fail. And that's a great way, or you can look at your contributed modules that you're using and see if they have that turned on Drupal.org, or run them yourself and see if they're deprecated things that they're calling, or use code inspections to look for deprecated calls. PHP Storm will hopefully put a little squiggle through things that are annotated as deprecated. So you're looking at your code and you're like, why is there a little squiggle through this method call? It's because it's deprecated. You should stop using, look at that documentation, figure out what to replace it with. So if you go that, start doing that work now, over time, you'll be ready for Drupal 9 when Drupal 8 is end of life. Okay, so getting towards the end here, OWASP 10 number 10. Again, this is sort of broad topic, insufficient logging and monitoring. This is maybe not a vulnerability in and of itself, but often when people's sites are compromised or their networks are compromised, they're not aware they've been compromised, sometimes for months after it's happened. Right? You read high-profile cases, literally months. Attackers are in there, stealing people's data, changing things, having fun, reading the CEO's emails, whatever was happening, right? And they had no idea. So, is your Drupal site, does it have logging turned on? Where are those logs going? Are the logs being stored somewhere centrally, let's say, or on a different server than the Drupal site itself? So, if Drupal can write the logs, Drupal could probably overwrite the logs or delete the logs, right? So think about that. If someone compromises the site, do you have confidence that the log files have not been tampered with, and that you could go back and reconstruct and figure out when that attack happened, what IP address they were coming from, what account they used to log in with? So read your logs. There are services will help basically trace through your logs, look for anomalies in the data. Let's say unusual activity in your logs. That's something good, especially if you have a higher profile site or more important site. Have some kind of centralized logging. Don't store your logs only in the Drupal site. Have some kind of permanent copy that's not just on your web server, that's somewhere central. Okay, so that was the OWASP top 10. Getting towards the end of our time, so try to run through the rest of this pretty quickly. We've already taken some questions. If people have questions, go ahead and raise your hands. Otherwise, I'm going to run through this really quickly. This is cross-site request forgery. So this was on the OWASP top 10 in 2013. Was removed in 2017, but is actually still a vulnerability we see commonly in Drupal, and that's why I wanted to mention it. And cross-site request forgery sounds complicated, but the simple example here is that I have a menu path like that where an administrator who accesses the path causes some destructive action to be taken, like deleting content on the site. And you may say, why is that? I, as administrator, wouldn't do that. Sure, of course you wouldn't, right? But the attacker is like, hey, I'm going to post a blog post. I'm going to construct an image tag that deletes that important content on your site if your browser tries to load the image tag, right? And now they send you a nice email saying, would you please read my blog post and tell me what you think of it? You go to their blog post. Again, this is a target attack, right? You go to their blog post. Your browser tries to load that image with that source. It has your cookies. As the site administrator, you're logged in. That content is now, your pants are gone, right? So this is a fun old example. All your pants are in danger. So you're now exposed. So anytime you're doing a write operation in Drupal, so the thing about this is you need protection against cross-site request forgeries. Anytime you're modifying data, deleting data, easy way is to use the form API in Drupal. It provides automatic protection against this. Security tokens for GET requests, like we're showing here, are actually automated in Drupal 8. So there's a way that in your route definition, you can say this path requires a security token, and that will automatically be provided and validated. Don't think that post requests are safe from this. You can use JavaScript, can send a post request on behalf of the attacker. You visit their blog. They've written some JavaScript that takes your browser and essentially sends a post request to your site. So you can be vulnerable. Just pause here also. This is a reason I'm also mentioning this is there's a big push towards writing, let's say, headless front-end interfaces for Drupal. So I'm sure people have all heard about this as a hot new thing, right? I want to have a sexy JavaScript front end. I'm using React. I'm using something. to pull data out of my Drupal site, present it to the user. If you start re-implementing forms in Drupal, re-implementing the login, re-implementing different things using that front end, it's pretty easy to forget to apply any kind of cross-site request forgery protection, right? So now you've basically built up an API in the back end. You have a front end where the user is allowed to post things in or make some requests changing data. And if you don't have that cross-site request forgery built into your front-end API, you might have made your Drupal site vulnerable to cross-site request forgeries, again, even though Drupal core would have protected you. So that's, again, the reason why I wanted to emphasize that. So again, the big pattern, user data can be used to attack you anytime the data is coming from the user, which means any kind of GET request, things in the URL, things in the user's cookies, anything the user is allowed to save, whether writing a comment or a node. And basically use that. If you trust that user data, the attacker can use your browser against you, basically. And again, known vulnerabilities. If the vulnerability is known, the attacker can mass attack sites. You'll see it all the time. If you look at your logs, you'll see that people are trying to attack your site all the time, right? And it's not because they care about you. It's because there's a known vulnerability. If they find a Drupal site with that vulnerability, they're going to hijack it. Okay, so all right, we're at the hour. I think we have potentially 10 more minutes, so I'm going to run through this stuff quickly. Again, if you have questions at this point, stop me. We're through the top 10, so that was the key parts. And I'm going to give you a little bit on kind of best practices, being prepared. So be prepared for an attack, right? Assume that it's going to happen. You should have your code version controlled, make backups, test your backups, force each administrator to have a separate login, have some way to access your site if it's compromised, like have SSH access with Drush. Again, logs. We talked about insufficient logging. Make sure you know where your logs are. Ideally, copy them somewhere centrally that's not on the web server. All these things will help you be prepared to recover from an attack. You should assume basically at some point you're going to be attacked, you might be compromised, and you should be prepared to recover. So if you're prepared to recover, it's going to make this attack an annoyance and not devastating, not put you out of business. So then you can recover, right? You need to know when you were compromised, what was compromised, restore from backup, update all the code, so figure out what that vulnerability was that you hadn't updated. Have a process for changing your passwords and keys, right? If you can't change your password because it's going to break everything, break your integrations, that's you're not going to be able to recover. Audit your code, right? So if there was a compromise, you don't know where it came from, you're going to have to go back and look at your custom code, especially, or your theme, and say where in there is there something subtle that I missed. And again, look at your logs. Try to figure out, often you can look at the paths that the attacker used. From the path, you can figure out where that vulnerability, or narrow down the vulnerability in the code.
Are there static analysis tools that can help us find some of the more common ones?
The static analysis tools will find the examples I showed you, basically, the things that, looking at it as a halfway knowledgeable developer, you would jump up and down and scream. Those are the only things that static analysis tools will find.
Okay.
So, yes, but for the most part, static analysis tools will generate 99.9% garbage output and at best 0.1% useful. So you have to have a lot of time and someone skilled enough to read the output of that and know. I mean, there's some that will only look for those really obvious examples and flag them. Like I think the code sniffer with coder module, will potentially flag the super obvious ones and won't give you a lot of noise. So that's fine. But if you use like a commercial vulnerability analysis tool, I've seen those. It's very frustrating because they'll tell you that they think there's all these vulnerabilities, and it doesn't understand how Drupal works. Spend a lot of time.
Yeah, I was hoping there would be some that are Drupal specific that would be able to say, hey, I see a DB select on node, but there's no add tag node access.
Yeah, I don't even know that there's anything that specific because again,
there isn't anything that's that complicated. Whenever I have to do an audit of a site, and I've audited a lot of sites, I don't even use one of those checkers. They are a waste of my time. I usually go right for their custom modules and I look through every one by hand. And it takes an afternoon, but you usually find a lot of things. And I found some I've had trouble sleeping lately.
Right. So you see here, right here, exactly. Audit the code, custom modules, right? That's where the vulnerabilities are going to tend to lie, because those have not had any degree of public exposure. They're not on Drupal.org. They don't have other people looking at them. So some useful security modules. So there is this security review module. Kind of look at your site configuration. Paranoia module, more useful for Drupal 7, but helps do things like block user 1. Helps try to prevent PHP evaluation in Drupal 7. This SecKit module will help you enable constant security policy I mentioned earlier. So look at that module. Drupal 8 is more secure. So we have auto escape. So in templates, we by default all user content is escaped. Have, as I said, cross-site request forgery, token support, and some other improvements. And the PHP module is no longer even in Drupal core, so you don't have to worry about that. There's no PHP execution through the Drupal user interface, with some little caveats we could talk about if you want. But in general, it's a lot harder to execute, and for an attacker to get access to execute PHP in the Drupal UI in Drupal 8 as opposed to earlier versions of Drupal, where it was kind of like a standard thing. Okay. Let's just finish up. Let me run through this real quick. So I'm on the Drupal security team. Basically, the Drupal security team is volunteers, first off. And the job is basically just coordinating security releases. The security team does not audit code. We basically just handle responsible disclosure, meaning someone tells us there's a problem, we handle it in private, coordinate with the maintainers, and do the release. And then you help define the policies and the risk levels. So again, we're volunteers. We're responding to vulnerabilities. We're not finding vulnerabilities. But again, you can follow on Twitter, on Drupal.org, sign up for newsletters. There's Slack channels. And you can look at the PDF and basically see this is the workflow process. If we get a vulnerability, again, it's about us coordinating it and responsibly disclosing it, not about us fixing it. I've talked a lot in this about best practices. Security is not a checkbox. It has to be part of your workflow. It's ongoing. You have to keep your modules updated all the time. You have to audit new code all the time. Sorry, that URL is a little broken, but again, your hosting matters. Is hosting a Drupal site your primary business? If not, probably you shouldn't be running your own hosting. You shouldn't be using shared hosting. Why does someone want $10 a month hosting the website they just spent $100,000 to implement? Doesn't make any sense. I know, yes, you're crying. So multi-site can also be problematic, or multiple web applications on the same host with shared access to PHP. You'll often see one web application will be used to compromise all the other web applications on the same host. So again, security strategies, think about trust, that's CI triad, least privilege, don't give people access they don't need, be prepared, and again, software updates. As many times as I can emphasize, keep your site up to date. Some links here, and with that I will end. If you have more questions, thank you. Otherwise, we will have a few minutes to move on to the next session and get some coffee. Thank you. Welcome.
You said the PDF was where?
It's on